Good morning, guys. This is Mrs. Harbin, and this is the presentation for section 1.6, Applying Equations for Advanced Math. Our biblical application is this. God is concerned about numbers. He created them for our use to help us be organized and orderly. And if God created something for us to use in an organized and orderly fashion, then we need to do our part to make sure that we are using those numbers correctly and to help ourselves be organized and orderly. Our objective for today is this. You, the student, will solve problems involving number and angle relationships. We're going to be taking a look at word problems and how we can represent these with algebraic equations. Let's try this one. Write an equation using one variable and then solve. And here's the problem. We want to know the rate at which Bryce traveled a distance of 156 miles in 3 hours. Let's say Bryce is on his way home. He drives 156 miles and he gets there in 3 hours. His parents want to know, Bryce, how fast were you actually driving? We're going to use this formula that rate times time equals distance. Rate times time equal distance. If we're driving 60 miles an hour and we drive for 1 hour, then we can figure out we drove 60 miles. So let's see how fast Bryce was driving. We know his time is 3 hours, so we're going to plug that in right here. And we know his distance was 156 miles. What we're solving for is rate. And we're going to use the variable r just to help us remember that we're solving for rate. Well, to solve for that variable, that r, we have to undo what's been done to it. Right now we have 3 times r. The inverse operation of 3 times r is dividing by 3. Multiplying and dividing are inverse. Whatever we do to one side, we have to do to the other. We've got to keep that scale balanced. And when we divide 3 by 3, we get 1. So 1r equals 156 divided by 3 is 52. So we can figure out that Bryce was driving 52 miles per hour. Don't forget to put that little distance and time tag there at the end, which we get from the original equation. So he wasn't speeding at all. Let's write an equation using one variable and then solve. A room has a length of 3 feet longer than its width and a perimeter of 78 feet. Well, let's think for a second. A room is usually rectangular, so we can go ahead and think about a rectangle here. And what do we remember about perimeter? Well, if you remember anything about perimeter, you remember that it's all the sides added up together. So if we add the width and the width and the length and the length, add all 4 sides, then we get the perimeter. And we're told that the length is 3 feet longer than its width. So whatever the width is, we know that the length is 3 feet longer than the width. We can use this expression 3 plus w then to plug into our perimeter formula. So there's a good picture of a rectangle there. And we know that the perimeter is 2 times the width, or width plus width, and 2 times the length, or length plus length. We don't know the width. That's what we're trying to solve for, so this stays the same. However, we do know that the length can be written as 3 plus w. So we're going to substitute that in right there where we see that L. Okay, then using the distributive property, order of operations, and everything we've learned about solving algebraic expressions, we can get down to 4w plus 6 equals 78. Let's move that 6 over so it's on the side with the other constants, and we get 4w equals 72. And how do we get the 4 by itself? Well, remember 4w is just 4 times w, so we've got to use the inverse operation. And the inverse of multiplication is division. So let's divide both sides by 4, because whatever we do to one side, we have to do to the other. And when we do that, we find out that the width is 18. And again, don't forget your unit rate here. What are we measuring in? It is 18 feet. So a pretty good size room. Now you will be asked occasionally to do problems involve finding consecutive integers. Consecutive just means one after the other, and integers was our numbers 0 through infinity, and their opposites, so -1 through infinity. So it's all of our negative and positive numbers. And when we're looking for consecutive integers, we could use a variable like n to represent the first number. The number that comes after it would be n plus 1, And the number that comes after that, can you guess? N plus 2, and we could keep on going, 3, 4, 5, depending on how many consecutive integers they're asking us to find. Sometimes they'll be asked to find consecutive even or odd integers. Well, even and odd integers are 2 spaces apart in the number line. So our first number, our starting point, is n, and the even or odd, next even or odd number is 2 spots later. So we would represent that as n plus 2. And the next one is n plus 4, and what would be next? N plus 6. Nice job. So we need to find the sum of 3 consecutive integers, which is 24. A sum I know means I'm going to have to add. Consecutive integers, that's what we just talked about, is an equal sign, 24. Which integers are they? So I'm going to take my first integer and represent that as n. That's my first one. What would my second integer be? N plus 1. And my third integer would be represented with n plus 2. Now I know that when I sum all of these or add them all together, I'm going to get 24. So let's write this equation. First integer, n, plus second integer, plus third integer, all together is 24. Using what we've already learned earlier this chapter, we're going to combine like terms. 3n plus 3 equals 24. We are going to subtract 3 from both sides to move that 3, if you will, over to the other side of the equation. Get rid of that 3. And then we have to divide by 3 using the inverse operation of multiplication, and that tells us that n equals 7. Well, if the first integer, n, is 7, what's our second integer, n plus 1? Hopefully you said 8, and the third integer is 9. Nice job if you did those. Here's another formula that you need to be familiar with. Simple interest formula. I equals PRT. Now, if you don't understand or didn't understand how banks work, essentially when you put your money in a bank, you are giving your money to the bank for them to borrow. They are using your money, and they're paying you to use their money, and they're paying you in something called interest. And some banks pay you more money than others. So it's always a good idea to shop around at different banks and see how much interest they're paying you to borrow your money while it's in the bank. You can figure out how much interest you're getting or how much money you're getting paid with your money in the bank using this formula. P is principal. That's the amount of money that you put in the bank or that you invest. R is the annual rate of interest. And T is the time of the investment or loan in years, how long you're leaving that money in there and not touching it. I is the amount of interest on the investment or the loan. Again, you're also gaining interest when you put your money in a bank account. They're paying you interest to keep your money in their bank. So let's take a look at this. Leslie has $20 in a savings account that earns 5% annually. Now, I will tell you 5% is really high. One of the higher banks right now, Goldman Sachs or Marcus Banks, actually pays 2% interest in savings, and that is really high. Most local banks are around 1% interest. So 5% is an incredibly high rate. Hopefully one day we go back up to that. Anyway, she's earning 5% annually. This interest is not compounded, which means it's just 5%. It never increases, it never doubles, it just stays 5% interest. How much money will she have in a year? Well, let's use that formula. We need to, first of all, change our percentage to a decimal so that we can include that in our formula, and 5% is represented as 0.05. Using this formula, I equals PRT, what do we know? We know the interest, 5%. We know the principal, $20. And we know the rate, not the interest, which is 5%. We know the principal, and we know the time. And the time is going to be 1 year. We're trying to find out how much interest she's earning, how much money she's making. When we plug in all those numbers, 20 times 0.05 times 1, we find out that they paid her $1 that year. So how much money did she have at the end of the year? $21. Now that may not seem like a whole lot, but imagine that you've invested $200. You just earned $10. Or $2,000. You just earned $100 just by leaving your money in the bank. So when you do deposit your money, make sure you're looking for a bank with a good interest rate. Today, we solved word problems using everything we have learned from this chapter. Distribution property, combining like terms, keeping our equations balanced, representing unknown numbers with variables. If you guys have any questions, be sure to ask me next class.